Hey everyone, in last video we understand how the reflection agent works, okay? So now we have a lot of information about generative AI, okay? We can say or agentic AI. We know lang chain, lang graph. We also know how we can develop a CLI agent, okay? Chain of thoughts, all those prompting, okay? How many types of prompt, okay? We know the memory, okay? Our graph memory as well, simple. We use Neo4j, we use MEM0, okay? Yeah. So as of now, we have a lot of information about it, okay? Yeah. Okay. So since there is a lot of AI systems available on the internet, okay? You can see and maybe they can write code, okay? They can reason, they can plan, okay? There's a lot of things, okay? Yeah. So if I'm talking about a big problem here, okay? Like you have an agent, a dedicated agent, okay? Which can write code, which can plan something, okay? Yeah. Okay, so the problem is the task is still to writing code and all thing, okay? Yeah, but whenever the task is changed, okay, so of course our agent will be retrained, okay, if the task is different from previous one, okay. Basically our agent does not know how to perform this, okay. Yeah, so of course we need to retrain our agent, okay. Yeah, so what does mean? That means we need more time, okay, and we need to more data for the computation, okay, and the more compute, okay. So for this, what we need to do, we need to restart our agent. Okay, of course, we need to first apply those changes. Fit then we need to restart our agent. Yeah, then it will able to basically adopt the new change. Okay, yeah, simple. Okay, so what if it could adopt instantly? Okay, we don't need to tell explicitly like if any new tasks are coming. Okay, and our agent are blank. Okay, no. And in that case we need to retrain that our model and restart, okay, but we can also make it very fast, okay, and it any new task are coming, it is adopted by very quickly, okay. How we can do? Okay, so that's where a meta learning comes in, okay. The meta learning comes in, okay. Yeah, so here the meta learning comes in the picture, okay. ah So, of course, today we are going to breaking down how the AI learn, how to learn. Okay, yeah, simple. So, first we understand what is the limitation of our traditional ML. Okay, yeah. So, let's just simple take an example. Okay, like we define a task. Okay, and we have some data, and we train a model. We just deploy it. Okay, yeah. Now you can see I basically train basically I train my model to classify between the cats and dog. Okay, simple. I train my model which will classify between cats and dogs. Simple. After deployment, I just ask this and it work perfectly fine. Of course, it will work perfectly fine. Why? Because our model trained on this only. Okay, yeah, simple. But after some time, what happened? You need basically classify horse versus cow. Okay, yeah. So in this case, what happened? Okay, you need to retrain your model from the scratch. Okay, yeah. So this approach we need require a massive amount of data set, okay, of course the computationally expensive, okay, and it does not adopt well, okay, and of course the real world is a dynamic, okay, so it's a fail in the dynamic environment, okay, yeah, okay, simple. So we need to AI system that adopt not restart, okay, so this is the problem main, okay, why we need the system like which adopt very quickly. We know we don't need to restart our system, okay, and do the all those things to retrain and then okay, yeah, simple. So what is meta learning? Okay, now we can understand, okay, now we know why we need to learn meta learning, okay, simple. So we can say it's in simple word, okay, meta learning is a changes the objectives, okay. How it change the objective? Simple. Let's I am asking a question, how do we solve this problem? Okay, simple. But in the meta learning, how do we build a system that learns a new task quickly? Okay, so meta learning is often described as a learning to learn, okay. Instead of training on one task, we train across many tasks, okay, yeah, simple. The model learn patterns of adoption, okay, over time it become a faster learner, not just a accurate learner, okay, simple. So this is the main key difference between, okay, yeah. So let's discuss what is the core idea, okay, simple. So just imagine, okay, you train across 100 of mini tasks, okay, simple, like you have to classify shapes, you have to classify animals, okay, you have to detect some anomalies, okay, you have to predict some trend, okay. The goal is not to basically master each task individually, okay, simple. The goal is to master adoption. We want to develop a AI system which will adopt anything very fast, very quickly, okay, simple. So what happened? Our model will learn how to update weights efficiently, how to extract usable features, how to generalize quickly. Okay, so it's develop a meta level understanding of learning. Okay, yeah. So mathematically, instead of optimizing, okay, we optimize performance after adoption. Okay, we train parameter 0 such that adoption is small update, performance is high. Okay, simple. So what happened here? Let's see. Okay, simple. We create a AI system and train a simple data set, okay, and once the new type of task is coming, okay, it's adapt very quickly, okay, and it's day by day become more and more powerful, okay. The adoption is very high and it's become very powerful. Of course, whenever it's getting a lot of information, basically lot of tasks, okay, and it will adapt very quickly and understand everything, okay, yeah, simple. So there is a multiple algorithm available, okay. So let's talk about the one of the most famous meta learning algorithm, okay. It's a MAML, okay. What is this? The model agnostic meta learning, okay. It's a developed by researcher, okay, and the researchers belong to Stanford University, okay. So how it's work? Simple. It's a like the simpler task, okay, simple. We have a simpler task. Take a few gradient updates, okay, simple. Evaluate performance, update to the original model initialization, okay. What is the goal? Find model parameter that are sensitive to change, simple, okay, which is not change very frequently, okay, simple. So an initialization that can adapt quickly, okay. So and it's model agnostic, meaning it's work with the there's a lot of things like we can say neural networks, CNNs, reinforcement learning agents, okay, regression models, okay, yeah, simple. And there is a multiple types of meta learning also available, okay. There is a three major types. The first is the matrix based, okay, okay, let's write here. The first is metric based. What is the metric based? These methods learn very similarity, okay. What is the similarity means? Used in the few sort learning. What is the few sort learning? They compare new examples to stored prototypes very efficiently when data is limited, okay. Like you have created a chatbot system, okay, not chatbot, you are getting any agent, okay. So simple. You need to prepare a system prompt. In system prompt, just give it two or three examples, okay. Like you have to act like this. Basically you have to perform like this, okay. So this is called a few sort learning, okay, simple. It's using a few examples. So this is the matrix based, okay, yeah. So it's a very good in that case when the data is very limited, okay, yeah. And we can say the second is the optimization based, okay. We already discussed algorithm MAML, okay. They optimize initialization or update rules, okay. They shape how learning happens, okay. We need to figure out which data, which point is not changing frequently, okay, which is very sensitive to change, simple. So using that the MAML is work, okay, simple. What is the third type? The third type is the model based, okay, yeah. So in the model based, simple, the model based, okay. So in the model based, basically it's these are use the memory systems, okay, the external memory, recurrent networks, attention mechanism, okay. This is very similar to modern AI agent with the memory layer, okay. We already know there's a lot of memory layer. We use the RAG, okay, for the external resources. If we need to talk our external resources, we need to tell our LLM like, hey, I have this kind of information which is available somewhere else, please use this information to give the response, okay, simple. So that is called external resource. We need drag like this, okay. We already know the better in memory layers, okay. There we used mem0. There are multiple type of memory, okay. The episodic memory, okay, the factual memory, and semantic memory, okay, simple. Okay, so now I think I hope you got the clarity what is the meta learning, why we need, okay, what problem it will solve, okay, yeah. Now let's understand in AI agents, okay, meta learning in AI agents, simple. So it's getting very interesting, okay, whenever we are talking about the meta learning in AI agent. Okay, yeah, simple. So already we build a lot of agents. Okay, let's say if you are building an agent with the memory system, used mem0 or neo4j, it's up to you. Okay, you are creating a reflection loop. Okay, we already created our reflection loop. Okay, simple. If you are using the tool, you say the multi-step reasoning. Okay, and your agent, what happened? Learn from your past failures, improve its prompting strategy, adapts to user preferences. Okay, that's meta learning behavior. Instead of just solving task, it improves how it solves task. Okay, simple. So you can see I already couple of times I discuss you too. We need like we get the some raw data from our LLM. Okay, we need to validate that data. If that is there's some anything is missing, or anything is not good, or something feels like it's vulnerable, not vulnerable. Okay, we can say it's harmful for our system. Okay, so that's why we are created our two tools when we are building a CLI agent. Okay, in that case you can see I have built a system, I have built two tools for the creating files and folder. Okay, maybe sometimes from the LLM we will get any command which is harmful for our Windows. Okay, Windows, Linux. Okay, anywhere. So for that we need to first verify that is not harmful for our system, then you can create it. So simple. So you can see day by day it will improve. Simple. Okay, yeah. So the meta learning behavior, let's discuss again. Okay, what is the meta learning behavior? Instead of just solving task, okay, simple, it will improve the how it solve task. Okay, simple. Let me you can see. Okay, let's see here. Okay, yeah, this is generate. Okay, what happened here? This is called a feedback loop. Okay, we are just generating something, we just evaluating. After evaluating, we just reflect. Okay, our reflection loop happening, adjust, store somewhere else, and then improve. Okay, so already you know the reflection loop. Okay, in last video we build a reflection agent. Okay, there I am just using that. Okay, I'm just getting the response from LLM, save into draft, find the criticize here. Okay, and just fix that criticize. After that we just refine that data, and then basically produce the response, the final response. Okay, simple. Okay, so let's understand something else. Okay, something new. Okay, simple. So the meta learning versus the reinforcement learning. In reinforcement learning, okay, yeah, there is some confusion of course between both. Okay, yeah. So the reinforcement learning learn from the rewards and punishments. Okay, in reinforcement in sorry in reinforcement learning learn from the rewards and punishment, but in the meta learning we learn how to adopt across tasks. Okay, they are not any kind of competitor between both meta learning and reinforcement learning. Okay, you can even apply meta learning on the top of reinforcement learning. Okay, that creates agents that adopt extremely fast. Okay, simple. Now the only difference is that you can see the reinforcement learning means learn from the rewards and punishments. The meta learning is learns how to adopt across tasks. Okay, simple. Okay, so I think we discuss a lot of things. Okay, why this is matters. Okay, yeah. So we can say that the AI moves us towards, we already build the autonomous agents. Okay, you can say personal AI assistants, self-improving systems, low resource environment, static training. Okay, simple. The static training, we are talking, what is the static training? That static training, whenever we create a model, we deploy that model. Okay, if our model is not able to train on the new task, okay, that is not a very good. Okay, of course that is not enough for us. Okay, yeah, simple. So meta learning enables the faster adoption, better generalization, less data dependency, higher flexibility. Okay, yeah. So you can see the meta learning, it moves to AI closer to our human learning. Okay, simple. Human does not relearn everything from scratch. Okay, we adopt. Of course, if today I know JavaScript, okay, there is a lot of logic which I already know. If I want to learn some other language, okay, so yeah, my logical thing is good, so I can adopt it very quickly. If I know C++, of course I can easily adopt Java as well. Okay, yeah, I need to just, there is some syntax difference between both language. Okay, simple. Okay, so the traditional machine learning asks like how do we solve this problem. I already told you, like a meta learning asks how do we become better at solving new problems. Okay, so machine learning builds intelligent models, meta learning builds intelligent learners. Okay, so of course the future of AI is the adaptive AI. Okay, yeah, simple. So the meta learning, it's very important to learn. Okay, yeah, I think I told you a lot of information. Basically, I share to you a lot of information about this. Okay, yeah, simple. Okay, so thank you.